On our geometrical ratio, the aspects of similarity. We are giving this diagram today in our example 3. We are asked to find the value of Vx. Vx is there. We want to establish that these two triangles are similar. First of all, the fact that we are giving, unlike in example 2, where we are giving examiner marks some angles equal already. So we use that to establish the similarity of the two triangles, because we know when the three corresponding angles of two triangles are equal, then we say the two angles are the two triangles are equiangular. And two equiangular triangles are said to be mathematically similar. And the fact that two triangles are similar does not mean they are congruent. They are not of equal size, but they look alike. So, and in that case, two similar triangles will have the ratio of their corresponding size constant or the same. Let us look at this. Can we say that since this VW equals to VY, VW equals to ZY by this parallel, since the two of them, since VW is parallel to ZY, then we can conclude that the angle at V equals to the angle at Y. That is alternate angle. Look at it from something like Z, alternate angle. In a similar way, angle at W is also alternate to angle at Z. So equal to this angle here. And we said that if two angles are equal for two triangles, we can conclude that their third angle will be equal. Reason, sum of angles in a triangle. If you add these two angles together and subtract from 180, what you will get for this smaller triangle is what you also get for the bigger triangle. Or if you look at this space, we can see that the angle here, the angle at X for each of them is equal. The one here is the same thing as the one here. That is vertically opposite angle. Vertically opposite angles. So since we're able to establish that the three angles are correspondingly equal for the two triangles, and we can conclude that they are similar triangles. So we can now just arrange the first one the way you want. Just a triangle, maybe VWX is similar to triangle. If I choose V here, which one is corresponding to V in the bigger one? Y. Y. Then W corresponds to Z, and X corresponds to X. So the two triangle VWX is similar to triangle YZX. I said the order of your letter matters a lot. From there, you can now choose the ratio of their corresponding size. If I choose VW here, that's the first two letters, VW in the smaller triangle, you take it as ratio of YZ. That's the first two letters in the bigger one. YZ equals to, let me choose, since I first choose from this smaller, I will always first choose from the smaller in my ratio. But suppose from this one I first choose, it will always be from this, before this. So it will be maybe YZ over VW equals to ZX over WX here, so on and so on. So I want to choose WX here now over ZX. Then VX over YX. So I will move on to the diagram and substitute the values. Let me substitute the values. What is VW in the diagram? Not given. VW It's not giving. Ratio YZ. What is YZ? YZ is 20. Equals to Vx. What is Vx? Vx is not giving, and that's what we have to find, over, oh, sorry. The next is Wx, not Vx. The next is Wx. What is Wx? Ws is 6 on the diagram. That is 6 over Zx. Zx. Where is Z? This is X. 12. Equals to, lastly, Vx. That's what we are finding. Vx divided by Yx. And what is Yx? That is 16. Since it is, suppose VW we are finding, would have equated these two ratios and solved. But since it is Vx, we have to find, equate these two ratios and solve. So that means you can cross multiply for them. If you have 16, if you have 6 over 12, 6 divided by 12 equals to Vx over 16. Cross multiply, you have 12. Vx equals to 6 times 16. Then you divide both sides by coefficient of Vx to get Vx. So Vx becomes, but the value of multiplying 6 and 16 together should give you 96 over 12, which implies that 8. So we have 8 centimeters. So from here, we move on to example 4. Still on geometrical ratio, aspect of similarity.